These are solutions to exam number 2 for Nelham's Math 110B class at City College of San Francisco. Number 1, integral of e to the x sine x dx. So we'll integrate by parts. Let u equal e to the x dv sine x dx. Differentiate, du is e to the x dx. Integrate, v is equal to negative cosine x. By formula, I is equal to u times v, so it's negative cosine x times e to the x, minus the integral of v du, minus, there's a negative, so I put a minus 1, e to the x cosine x dx, there's a double negative, so negative e to the x cosine x plus the integral of e to the x cosine x dx, I'm going to call that I1, and work on integrating this one by parts. So the original I is negative e to the x cosine x plus I1. And now we take a time out to figure out what's I1. So I1 is the integral of e to the x cosine x dx. Integrate by parts again. U equals e to the x. dv is cosine x dx. du is e to the x dx. v is equal to sine x. So I1 is u times v, e to the x sine x, minus the integral of v du, e to the x sine x dx. And notice this is the same as the original, so I'm going to call that I. So I is equal to negative e to the x cosine x plus I1. I1 is now this, e to the x sine x minus I. So I've got an equation that has I here, a negative I here. So I'll add I to both sides. I get 2I equals, these two terms have a common factor of e to the x, so I factor out e to the x, and I'm writing it as sine x minus cosine x. Divide by 2, so I is 1/2 e to the x sine x minus cosine x plus c. Number 2, the absolute easiest way to do this is change it to the integral of ln x to the 1/3. Cube root of x means x to the 1/3. Bring the 1/3 in front. Property of log, in fact, you can pass it all the way out. And so you have 1/3 the integral of ln x dx, and that's 1/3 of x ln x minus x plus c. Okay, you could memorize that, you could put that on your cheat sheet, or you could integrate that by parts, but we talked about that. Integral of that is just that. Number 3 fits the category of having an odd exponent, sine cubed cosine squared. So write it as cosine squared x sine squared x sine x dx, which now means I want all of this stuff to say only cosine. This is already cosine. I have sine squared x, which I can change to 1 minus cosine squared x. So let u equal cosine x. That would become u. That will become u. du is negative sine x dx, so I put a negative 1 inside and a negative 1 outside. So I has a negative u squared 1 minus u squared, and then negative 1 sine x dx, negative 1 sine x dx is my du. Distribute, negative integral of u squared minus u to the 4th. So I don't have to fool with the negative anymore. I distribute the negative in, and that means I get to turn these around as u to the 4th minus u squared. So u to the 5th over 5 minus u cubed over 3 plus c. Change u back to what it was, cosine x. So final answer of 1/5 cosine to the 5th x minus 1/3 cosine cubed x plus c. Number 4, the best way to integrate cotangent squared is to write it as cosecant squared x minus 1. Okay, and now these are elementary. Integral of the cosecant squared is negative cotangent x. Integral of negative 1 is negative x plus c. 5, integral of x cubed radical 4 minus x squared. So the substitution to make this time is let x equals 2 sine theta. Okay, so that fits this category of a squared minus x squared. Okay, so 4 minus x squared. So x is 2 sine theta, dx equals 2 cosine theta d theta. So x cubed is now 8 sine cubed theta. Square root of 4 minus 2 sine theta squared is 4 minus 4 sine squared theta. Dx is 2 cosine theta d theta. Now, if I factor 4 out of this, I get 4 parentheses 1 minus sine squared theta. And we know the next step, that's going to become 4 cosine squared theta. So leave that alone. 8 sine cubed theta, square root of 4 cosine squared theta, 2 cosine theta d theta. This comes out to be 8 sine cubed theta. That becomes 2 cosine theta times 2 cosine theta d theta. 8 times 2 is 32. And I have integral of sine cubed theta cosine squared theta d theta. And what do you know? That's problem number 3, except instead of using theta, it was x. How about that? Sine cubed cosine squared, sine cubed cosine squared. So since I just did that, there's no reason to reinvent the wheel. I'll just peek at the answer that I got back over here. So 32, 1/5 cosine to the 5th theta minus 1/3 cosine cubed theta plus c. It's the same thing as here, except instead of x is theta. Okay, so you're allowed to do that. Now I got to change theta back. So we said x was equal to 2 sine theta. So I triangulate with the triangle. That means sine of theta is x over 2. So I draw my triangle. Sine is opposite over hypotenuse. The adjacent side, you can either do a squared plus b squared equals c squared, or you can do the just sneak a peek at the original, look for a square root, and it's probably that, square root of 4 minus x squared. It is, but you can double check. What is this thing squared? 4 minus x squared. What is this squared? X squared. Add them up, you get 4, which is equal to 2 squared. So it doesn't work. All right, so I now have 32. So we have cosine theta here and cosine theta here. Looking for cosine. Cosine is adjacent over hypotenuse. So radical 4 minus x squared over 2. So 32, 1/5 radical 4 minus x squared over 2 to the 5th power minus 1/3 radical 4 minus x squared over 2 cubed plus c. And a little bit of cleanup. 32 cancels this 32. 2 to the 5th is 32. That will cancel this. Okay. And I'm going to write this as 4 minus x squared to the 5/2 power. That's probably the cleanest way to do that. Power is 5, the root is 2, and I still have a 5. Okay, and 2 cubed is 8. So this 8 in the denominator will cancel to 32, leaving me with a 4. And 4 times 1/3 is 4/3. 4 minus x squared to the 3/2 plus c. Okay, question 6. You should recognize that. So x is 5 tan theta. Dx is 5 secant squared theta d theta. So 5 secant squared theta d theta is my dx. Radical x squared is now 25 tangent squared theta plus 25. Okay. Again, in case you're wondering about the substitution, this is x squared plus a squared, which looks like the second one, that x equal a tan theta. All right, so I have 5 secant squared theta d theta over square root of 25 tangent squared theta plus 25. That's factor to 25. Tangent squared theta plus 1, which is the same as secant squared, whose square root is 5 secant theta. So 5 secant squared theta d theta over 5 secant theta. 5's cancel out. I have the integral of secant theta d theta. You can either memorize it or put that on your cheat sheet, hopefully. Or there was a way to work it out longhand, but I didn't really talk about it much. Anyway, it's ln absolute value of secant theta plus tangent theta plus c. And now triangulate. We said x was 5 tangent theta. That means tangent theta is x over 5. Tangent is opposite over adjacent. You can do your Pythagorean theorem to find the hypotenuse. Or again, just peek at the original and you're probably right. Square root of x squared plus 25. But again, let's double check. This squared is x squared. This squared is 25. Add them up, you have x squared plus 25, which is equal to the square of the hypotenuse. So we're good. All right, so ln absolute value. Secant is the reciprocal of the cosine. So that means it's hypotenuse over adjacent. Radical x squared plus 25 over 5 plus tangent of theta. Tangent is x over 5 plus c. You can leave your answer like that, but as I mentioned when I went over the quiz last time, this was a quiz question, if you notice. You can actually drop the 5 because you're going to end up with minus ln 5 plus c, but minus ln 5 plus c is just another c. And you could change this to parentheses because this expression is always positive, we said. Okay, so this is the best final answer. But I said I would accept that, so I will. Okay, 7, you did not have to actually find the coefficients. So we did some of these for partial fractions. So factor out the x cubed. So in the denominator, you have x cubed times x squared plus 25. This is an irreducible quadratic. So x cubed, you have to have x squared, and x cubed. X squared plus 25, you just leave it alone. And on top, you have a, b, c. But this being a quadratic expression means you need a linear expression on top. So dx plus e. And just stop right there. Number 8, you were supposed to do the whole thing. Okay, x squared minus 11x plus 30 factors into x minus 5, x minus 6. So we have negative x plus 8 over x minus 5, x minus 6. Okay, so I break it into a over x minus 5 plus b over x minus 6. Multiply this side by x minus 6 over x minus 6. This one by x minus 5 over x minus 5. Common denominator is x minus 5, x minus 6. So this becomes ax minus 6a plus bx minus 5b. Combine like terms, combine the x's. So I have a plus bx, and then the constant's negative 6a minus 5b. And I set this equal to the original numerator here. So I need this to be negative 1. I need this to be 8. So here we are, a plus b equals negative 1, and negative 6a minus 5b equals 8. 2 equations, 2 unknowns. Multiply the top equation by 6. 6a plus 6b equals negative 6. Add them up, a's drop out, you get b equals 2. And if you plug in 2 right here, it gives you a equals negative 3. All right, so that's going to be negative 3, that's going to be 2. So I is the integral of negative 3 over x minus 5 plus 2 over x minus 6. And in the final answer, I decided to put the positive first. It prevents you from writing one more symbol. You don't have to write that plus. So I'm going to go 2 ln absolute value of x minus 6 minus 3 absolute value of x minus 5 plus c. Okay, number 9, integral from 1 to 5 of 60 over x dx. Only use Simpson's rule, n equals 4 from 1 to 5. So very conveniently, chop it into 4 pieces. The n is 4, which means delta x is equal to 1. Okay? And the way Simpson's rule works was 1, 4, 2, 4, 1. So S4, meaning Simpson's rule, n is 4, delta x over 3, 1 f of 1, plus 4 f of 2, plus 2 f of 3, plus 4 f of 4, plus 1 times f of 5. Okay. Very conveniently, when you plug in 1, 2, 3, 4, 5, it was given that way. These all come out to be whole numbers. If you divide by 1, you get 60. Divide by 2, you get 30. Divide by 3, it's 20. Divide by 4, it's 15. And divide by 5, it's 12. So it's 1/3 of 1 times 60, plus 4 times 30, plus 2 times 20, plus 4 times 15, plus 1 times 12. Add them all up, 97.3 repeating. Okay, you didn't have to do that, but if you actually integrate it, okay, you get 60 ln 5, which is about 96.566. So you can see it's pretty close. Okay, and finally number 10, 1 over x cubed, integral from 1 to infinity. So 1 to infinity, treat it as 1 to b, and take the limit as b approaches infinity of x to the minus third. 1 over x cubed is x to the minus third dx. So limit b approaches infinity, x to the minus 2 over minus 2 from 1 to b. Factor out the negative a half. Limit b approaches infinity of 1 over x squared from 1 to b. So negative a half, limit b approaches infinity. Plug in b, 1 over b squared. Plug in 1, you get 1. Okay, so now when b gets super big, this becomes close to 0. So 0 minus 1 is negative 1. So I have negative 1 times negative a half. Final answer is 1/2. All right, so these are the solutions to exam 2 from Melham's Math 110B at City College.